Hi guys, welcome back to this channel. In this video, we are going to look at the topic sensors. Now, let's look at the meaning of sensors. So, sensor are input devices. It's a type of input devices, and this means that they collect data from real world, data from surroundings, data like temperature, pressure, acidity level, and length, and send these data to a computer system. But here is the thing, computers cannot directly understand these physical values, these physical properties, because they are analog and continuous data. So computer only understand digital data, digital signals, which are discrete. So that's where ADC, analog to digital converter, comes in. So the analog to digital converter will convert these real world readings into digital values that the computer can process. So sensors readings may cause the microprocessor, for example, um, alter a valve or a motor that will change the next reading taken by sensor. So the output from the microprocessor will impact on the next input received as it attempts to bring the system within the desired parameters. So this loop is called feedback. Now let's look at um, some sensors, their meaning, and how they are used in applications. So we have temperature sensor. So the function of the temperature sensor is to measure the temperature of the surroundings. And in what type of application is it used? It can be used in a central heating system. It can be used in a greenhouse. It can also be used in monitoring a chemical process. Then we have moisture sensor. So the function of a moisture sensor is to measure the water level, in example, in a soil. And it is used in applications like greenhouse to measure the moisture level in the soil. It can also be used in food processing factory to monitor the moisture level. Then we have light sensor. So the light sensor uses photoelectric cells that produce an output depending on the brightness of the light. And these sensors are used in applications such as switching street lights on or off depending on the light level. It can also be used to switch on car headlights automatically when it gets dark. Okay, another sensor is humidity sensor. So this sensor is slightly different from moisture sensor. What this sensor does is that it measures the amount of water vapor, the amount of water in the air. So it is used in applications such as measuring the humidity level in a building, measuring the humidity level in manufacturing companies. Also, we have infrared sensor. So this uses an invisible beam of infrared radiation picked up by a detector. So if the beam is broken, then there will be a change in the amount of infrared radiation reaching the detector. And this is used in applications such as turning on car windscreen wipers. Also, it can be used in security alarm system. Then we have pressure sensor. So the pressure sensor is a transducer and it generates different electric current depending on the pressure that is applied. So it is used to measure the amount of pressure that is applied. So it is used in applications such as weighing of lorries, measuring the gas pressure in a nuclear reactor. Then we have acoustic or sound sensor. So these are microphones that convert detected sound into electric signal or pulses. and they are used in applications to pick up the noise of footsteps in a security system, also to detect the sound of liquids dripping at a faulty pipe joint. Then there is pH sensor. So the function of the pH sensor is to measure the acidity through the changes in voltage, for example, in a soil. So they are used in applications such as monitoring or controlling the acidity level in the soil in a greenhouse. Also, it is used to control the acidity level in a chemical process. Another type of sensor is magnetic field sensor. So this sensor measures the changes in magnetic fields, and they are used in applications to detect magnetic field changes, for example, in our mobile phones. They can also be used in anti-lock braking systems of cars. Then there is accelerometer. So accelerometer measures the acceleration and motion of an application. For example, it measures the change in velocity. So you will find them in cars, and they are used to measure the rapid deceleration and apply airbags in case of car crash. Also, it is used by mobile phones to change between portrait and landscape mode. Then there is proximity sensor. So proximity sensors are used to detect the presence of nearby objects, and they are used in applications to detect when a face is close to a mobile screen, and it switches off the screen when heard to the ear. Okay, now let's look at monitoring and control system. So we are going to look at the difference between monitoring and control system and what they have in common. So this diagram shows how sensors fit into a larger system. So whether it is monitoring system or control system, the cycle is similar. So in both systems, sensor will send signals to the microprocessor or the computer, and then these signals are converted to digital if necessary by using analog to digital converter. And then the computer or microprocessor will analyze the data received to check it against a preset value. And then for monitoring system, so if the new data that is received is outside an acceptable range, a warning message is sent to the screen or an alarm is activated. And then the microprocessor or computer has no effect on what is being monitored, meaning that the aim is just to compare the data with the acceptable range and then send a warning message. So it does not have any effect on what is being monitored. Basically, it's just watching, monitoring the process. While a control system, if the data is outside the acceptable range, then the microprocessor will send signal to the actuator, okay, either to the valves, to the motor, or whatsoever actuator that is being used. And the output from the system affects the next set of input from this sensor. So basically, based on the data that is sent from the computer system, a change will be made in the outside world. Okay, there will be a change. Maybe it is to open the valve, turn something, or close something. So a change will be made. So that is the difference between monitoring and controlled system. Now let's look at examples of monitoring system. So we have monitoring of patients in the hospital for vital signs. So there are devices in the hospital that will monitor the vital signs of patients, like the heart rate, the temperature, and so on. Then there's also a monitoring system that monitors intruders in burglar alarm system. We also have a monitoring system that checks the temperature level in a car engine. And also, there's monitoring system that monitors the pollution levels in a river. So examples of controlled system. So we have turning street light on at night and then turning them off again during the day. You should see this in your surroundings, whereby the light goes off in the morning and then during the daylight, and then at night the light is switched on. Then we have controlling the temperature in heating system or air condition system. Also, an example of controlled system is chemical processes. So, for example, maintaining the temperature and pH of a chemical process. Also, control system is used in cars. Okay, for example, anti-lock brake when it is necessary. Then it is also used in controlled environments such as greenhouse. Now let's look at some examples of monitoring applications in a patient in the hospital. So in the hospital, there are a number of sensors that are attached to the patient. So the function of this sensor is to measure the vitals such as the temperature, the heart rate, breathing rate, and so on. And these temperatures are attached to the computer system. So the reason why they are attached to the computer system is so that the sensor can send data back to the computer system. And the computer samples the data at frequent intervals. Okay, the data that is received is sampled at different intervals. And then the range of acceptable values for each parameter is then keyed in into the computer system. Next, the computer system will compare the value from the sensor with the values that is keyed in into the computer system. For example, let's say the temperature that is keyed in into the computer system is greater than 35 degree. So meaning that if it is greater than 35 degree, then something needs to happen. Okay, so this can be the acceptable values, or let's say less than 35 degrees are the acceptable values. So the computer will compare the values from the sensor with the values in the computer system. So if anything is outside the acceptable range, meaning maybe the data that is received is 40 degrees Celsius. So this value is outside the acceptable range. So if it is outside the acceptable range, a signal is sent by the computer to sound an alarm. So if data from the sensor is within the range, then the values are shown either graphical in a graphical form or on the screen. And then the monitoring continues until the sensors are disconnected from the patient. So this is how the nurse, the doctors are able to know if anything is wrong with the patient, if there's any irregular readings taken from the patient, then this monitoring system will sound the alarm for the doctors and nurses to attend to the patient. Now let's look at controlled application. So an example of control application is street light. So the light sensor is what is used to take readings, and then the readings are sent to ADC. So the reason why it is sent to ADC is so that the data can be changed into a digital format and then sent to the microprocessor. So the microprocessor will sample the data every minute or at other frequency rate. So if the data from the sensor is less than the value that is stored in the memory, so the value that is stored in the memory, we call it preset value. So if it is less than the preset value, then a signal is sent from the microprocessor to the street lamp, and the lamp stays switched on for 30 minutes before the sensor readings are sampled again. So if the data from the sensor is greater or equal to the value stored in memory, a signal is sent from the microprocessor to the street lamp, and the lamp is then switched off. So the lamp stays switched off for 30 minutes before another sensor readings are sampled again. Okay, let's look at another example. So imagine a chemical reaction that only works for when temperature is above 70 degrees Celsius and the pH is below 3.5. So what happens? Now, the temperature and pH sensor will read data from the chemical process, and then this data is converted to digital using ADC and then is then sent to the computer. So if the temperature is less than 70 degrees Celsius, a signal is sent to switch on the heater. If the temperature is greater or equal to 70 degrees Celsius, then a signal is sent to switch off the heater. Also, if the pH is greater than 3.5, a signal is sent to open a valve and the acid is added. And if the pH is less than 3.5, then a signal is sent to close this valve. So the computer signals will be changed into analog signals using ADCs so that the system can control the heaters and the valves. So this process continues as long as the computer system is still activated. Okay, now let's look at another control application, which is greenhouse. And this is a great example of how multiple sensors are working together. So this greenhouse uses 5 different sensors: humidity sensor, moisture sensor to make sure the plants are not too dry or too wet, temperature sensor to control the heating or the cooling, then the pH sensor to keep the soil acidity at the right level, and then the light sensor to turn on artificial light on or off depending on the sunlight level. The sensor takes readings from the surroundings, and then the readings are converted using ADC, and then the data is then sent to the computer. After the data is sent to the computer, then the computer checks with the preset value. After checking the preset value, for example, humidity, if the humidity is greater than the preset value, it sends signal to the motors to open window, or it sends signals to the valves to spray water. Then moisture sensor, based on the data received, it can either send signal to switch on heater to dry or to open the valve to add water. Then temperature sensor, based on the data received, it can either send signals to the motor to open the windows or send signal to close window and switch on heater. For pH level, it can either send signal to open the valve to add acid or to send signal to open valve to add alkali. Then for light, it can either send signal to the motor to close the blinds or send signal to switch on artificial light. So this is how all of these ensure optimal plant growth. And just like other control systems, it uses feedbacks. So constantly checking, adjusting, and checking again. That is all about the topic sensor. Don't forget to like, share, and subscribe if you found this helpful. See you in the next lesson.